Hello, everyone. Welcome to today's lesson. In the fields of precision manufacturing and CNC machining, establishing a single-axis coordinate system is fundamental to ensuring part machining accuracy and efficiency. Whether it's for measurement, positioning, or machining of parts, an accurate and reliable coordinate system is essential. Today, we will learn how to establish a single-axis coordinate system on a typical CNC lathe part through practical operations. This will include how to import a 3D model, how to measure and determine the direction of the coordinate axis and the position of the origin, as well as how to set up the safety space and perform automatic measurement of the reference points. By the end of today's lesson, I hope that you will be able to independently establish a single-axis coordinate system on CNC lathe parts, including manually and automatically measuring reference elements, correctly setting up, and applying the newly created coordinate system. This will lay a solid foundation for subsequent precision manufacturing and CNC machining. Next, let's look at the actual operation. The next step is to import the 3D model. Click on File and Import, select the appropriate file format, and import the 3D model following the specified path. Click Import to bring in the 3D model. Step 3. Establishment of coordinate system. CNC lathe parts are typical rotor parts. We only need to determine the direction of the axis and the position of the origin. There is no need to lock the rotation direction. The common axis is typically defined by the assembly or the conical surfaces at both ends of the part. Due to the impact of perpendicularity between the end face and the axis, the origin of the coordinate system is usually set at the intersection of the axis and the end face, rather than directly at the center of the end face. In manual mode, switch the probe to T1A90B180. In program mode, measure the rotational axis reference element A. Perform the measurement in 2 layers, with 4 points measured per layer. Ensure the cylinder measurement length is as long as possible while avoiding interference between the probe and the inner wall of the hole. Once the measurement is complete, the measurement feature for cylinder 1 will be obtained and named CYLA1. Insert New Coordinate System. Insert Coordinate System New. Select the cylinder we just measured. Then click Y negative to align it. After that, select reference A1 again. Check the X and Z axes, click Origin, and then click OK. Next, manually measure the reference surface B. Measure the end face element for reference B. Note, avoid collecting points at the edge of the ring surface. Measure at least 3 points and name them PLNB1. Click on Insert Coordinate System New. Then select reference B, check the y-axis, and click Set Origin to y equals 0. After that, click OK. Press the Ctrl+Q to execute the above program. Follow the instructions and use the control box to complete the measurement of reference A and B on the workpiece. The correct coordinate system's origin and axis should be as shown in the diagram. Enable Safety Space. Click on Edit, Parameters, Settings to configure the safety space. Open the dialog box of Safety Space Definition. In the dialog of Size, preset a reasonable clearance space based on the model's clamping scheme and determine the distance from each safety plane to the edge of the workpiece. We can check the option of Show Safety Space to view the current settings of the safety space. In the dialog of End, set the planes and edges through which the probe can pass. If checked, it means the probe can pass through that edge. If unchecked, it needs to avoid the edge. In the dialog of Status, set the activity of all features to On, and check the option of Activate Safety Space Motion. If needed, you can also check the option of Show Safety Space. Click OK to complete the creation of the safety space. Next, proceed with the automatic measurement of the reference points. Switch the mode to Automatic and first measure reference A. Insert the Automatic Cylinder command. Change the name to CYLA2, set the center to 0, 0, 0, the surface normal to 0, -1, 0, and the angle to 1, 0, 0. Set the inner cylinder diameter to 35 and the length to 10. Enable the arc movement switch and check the Show Contact Points button. Click the Contact Path Properties button, set the number of points per layer to 6, the depth to 2, the end depth to 2, and the number of measurement layers to 3. Click Create and then close the dialog. Now, insert a new coordinate system. Select the CYLA2 cylinder, align with Y negative, and select the CYLA2 cylinder again. Check the X and Z axes, set them to 0, and click OK. Afterward, proceed with the automatic measurement of the plane. Click the Automatic Plane command, set the center to 0, 0, 0, the surface normal to 0, -1, 0, and the angle to 1, 0, 0. Change the name to PLN1B2 and set the measurement strategy to TTP Plane Circle. Click the Define Path tab, set the number of rings to 2, with the first diameter set to 39.5 and the offset to 11. Next, click the Select Measurement Points tab, check Total Number of Points, set the total number of points to 10, and click Select. Click Create and then close the dialog. Next, insert a new coordinate system. Select PLNB2 and check Y. setting y to 0. Then click OK. At this point, the coordinate system has been successfully established. Through today's lesson, we have delved into the process of establishing a single-axis coordinate system, including the importation of the 3D model, determination of the coordinate axis direction and origin, as well as the setting of the safety space. I hope everyone can apply the knowledge gained to practical work and continuously improve your CNC machining skills and proficiency. At the same time, I encourage everyone to maintain enthusiasm and curiosity for learning, continuously exploring and experimenting with new techniques and methods. Finally, please reflect on this lesson and complete the following exercises to consolidate the knowledge you learned today and deepen your understanding. That concludes today's lesson. See you next time.